In this lecture, we're going to cover acceleration. Acceleration is the rate of change of the velocity. So the acceleration is equal to delta v over delta t. If you're doing calculus, then it's dv dt, so it's the time derivative of the velocity function. Acceleration can also be written as v final minus v initial over t, or v minus v naught over t, and this is what we call a naught, v naught. Acceleration is a vector quantity, and I'm going to cross this next line out. It is a vector quantity, period. You will be using I hat or j hat to indicate the direction of the acceleration vector. Acceleration is going to be constant in this course, so we're not worried about it changing. So we're not going to talk about average or instantaneous acceleration. The units for acceleration can be derived by looking at the formula. We have delta v over delta t. V has the units of meters per second. T has the units of seconds. A meter per second is a meter per second squared. If you're unsure about this, let me show it to you this way. I always have to do this myself. You're taking meters per second and you're dividing it by seconds, right? Well, what do you do when you divide? You multiply by the inverse. So we're going to times it by 1 over seconds. Okay, multiply the numerators, multiply the denominators, you end up with meters over seconds squared. Okay, a lot of times you maybe think, well, wait a minute, don't these seconds cancel out? They don't. Acceleration is the rate of change of what? Did you pick D? I hope so. The unit for velocity is, okay, this is a trick question. The answer is B. We're looking for the units of velocity, not the units of acceleration. The metric unit for acceleration is which of the following? That's right, meters per second squared. A horse gallops with a constant acceleration of 3 meters per second squared. Which statement is true? The correct answer is D. The horse's velocity increases 3 meters per second every second. And that's what it means by acceleration. The rate of change here is 3. That's a positive rate of change. That means it's increasing. Is it increasing 3 meters every second? No, that would be increasing the displacement, not the velocity. Okay, so when you solve problems, you need to read the problem carefully. The next thing I recommend you do is draw a diagram. The reason for that is it's actually a really great tool to use when doing these problems. It also helps you to activate different resources in your brain that will help you solve the problems correctly. The next thing you want to do is list the given information. When I did this, this part here, list the given information and identify the unknown, sometimes that list will help you think about formulas that you know. Okay? Number 4 is choose the formula. So what you do is you look at your given information, you look at your unknown, and you choose a formula to use to solve the problem. The next thing you want to do, once you have your formula, is you want to rearrange that equation to get your unknown variable by itself. Okay, so you always want to solve for your unknown variable first before you substitute in your numbers. So step 6 is going to be to substitute the values in and solve the problem. The next thing you want to do, and this is very important, and a lot of students don't do this, you want to check your work. Make sure that you use the correct units, make sure that your units work out. So in other words, make sure the equation is correct. Also check and make sure that the answer you've written down has magnitude and direction. You also want to make sure you have the correct number of sig figs, the scientific notation if necessary, and you want to make sure that you include vector signs and direction if necessary. So let's go ahead and try a problem. When I get done reading the problem, I want you to go ahead and pause the video, solve the problem, and then go ahead and start the video again. Your velocity changes from 60 meters per second to the right to 100 meters per second to the right in 20 seconds. What is your average velocity? What is your average acceleration? Okay, so after you unpause your video, this is what we get. The average velocity, the change in velocity divided by the time is your acceleration. The acceleration should be 10 meters per second I hat minus 60 meters per second I hat, all divided by 20. And that is going to give us 2 meters per second squared I hat. Again, once I'm done reading the problem, pause the video, solve the problem, and then restart the video. Your velocity changes from 60 meters per second to the right to 20 meters per second to the right in 20 seconds. What is your average acceleration? Okay, so let's take a look at the solution. Okay, so our acceleration is equal to delta V over delta T. We end up ending with 20 meters per second. We started with 60 meters per second. Dividing that by 20 seconds, we end up with negative 2 meters per second squared I hat. Okay, your velocity changes from 50 meters per second to the left to 10 meters per second to the right in 15 seconds. What is your average acceleration? Okay, so let's take a look at the solution. Again, you should have already paused the video to solve the problem. So here we end up with A is equal to delta V over delta T. We end up with 10 meters per second I hat minus negative 50 meters per second I hat divided by 15 seconds. And that ends up giving us 4 meters per second squared I hat. This is where the vector nature of things can get you in trouble if you're not paying attention. Notice it says here that you're going 50 meters per second to the left. And notice here it says 10 meters per second to the right. So it's going to be 10 meters per second I hat minus negative 50 meters per second I hat, all divided by 15 seconds. Your velocity changes from 90 meters per second to the right to 20 meters per second to the right in 5 seconds. What is your average acceleration? Okay, so let's go ahead and take a look at the solution. We end up with A is delta V over delta T, which is going to be 20 meters per second I hat minus 90 meters per second I hat divided by 5 seconds. This ends up giving us negative 14 meters per second I hat. Meters per second squared I hat. Okay, in the next video, we're going to talk about kinematics equations.